Hello, everyone. Thank you for attending this session. In this session, we will discuss one of the most important engineering approaches that touch the large scale enterprise solutions. We will talk about the chaos engineering. We will take it from different aspects. Number one, we will talk about the definition of the chaos engineering and the benefits of applying such approach. And we will talk about the tools, and we'll take a case study from solution architecture perspective that can propose for us different approaches for implementing the architecture of the solution. And then you are increasing the resiliency and the stability and the security aspects of the solution. So let's move forward. Let's start with the definition of the chaos engineering. Chaos, you know that it's unorganized and unknown behavioral aspects of the solution that you may face in the future. And then how can we relate this to the engineering? So organizing this chaos and taking proactive decisions regarding managing the chaos, this is the engineering that we should tackle within this session. So the chaos engineering, it's the practice of introducing unexpected failures for the solution in order to increase the resiliency and the security of the solution, which touch the non-functional requirements of the solution architecture, so it increases the quality of the infrastructure and as a consequence the architecture of the solution. For example, I will give you manual example that the all teams used in applying such approach. They if you have at your infrastructure, if you have around 10 nodes that running parallelly to and used from the load balancer, you can shut down one of the nodes, and then you can simulate what is the impact of the shutting down such node on your solution architecture. And the same from the database infrastructure perspective, you can shut down one node from the cluster and you can see the impact of shutting down such node. So this is in a nutshell the chaos engineering, being ready for the unexpected failures in the future, and you managing such aspects by proactive simulation. And currently there is an automation tools that enable you to manage the chaos engineering. So what are the key advantages and the objectives of the chaos engineering? Number one, increasing the security aspects. As we mentioned, there is a triangle for the security, and this triangle, it's the CIA, the managing and securing the confidentiality, managing and securing the integrity, and finally managing and securing the denial of services. So at this case, we are securing the solution from the denial of service, as impacting the infrastructure by shutting down one of the nodes that can cause potential denial of your services. So how can you behave in such situations? So that's what we will discuss in the next slide. In addition, increasing the solution resiliency, and the resiliency means there is a proactive engineering approaches that you can apply. Like buffering the potential resources that manage your infrastructure, like in implementing the caching layer, and additional implementation of the required design patterns that require to implement and managing the chaos engineering. Number three, reducing the mean time to recovery. If you have e-commerce, large scale e-commerce solution, for example, like Amazon, and for sure they are implementing such approach. The impact of the shutdown of the solution, it impacts the revenue stream of your business model. So implementing proactive chaos engineering approach and capitalizing on the existing tools for chaos engineering For sure, it will guarantee your revenue stream and your forecasting for your revenue stream and increase your solution security and increase your solution resiliency. So one of the objectives of the chaos engineering is reducing the mean time to recover and even the mean time to repair. Number 4, building the confidence of handling unexpected behavior and unexpected events within your solution. And that makes you confident about your infrastructure and readiness for the future. So moving forward, what are the key tools that are using for the chaos engineering? There is I will tackle only the commonly used and well-known tools. There is Gremlin, and it's a very simplified one. There is Chaos Monkey, and this is used and capitalized by Netflix. There is Litmus Chaos, and this is Kubernetes based, and you can apply it on the Redshift, OpenShift. So you can apply such tools on your technology stack, and the most one for old engineering approaches and the modern engineering approach, it's a Gremlin. You can use this tool within your old technology stack and within also microservices technology stack. So let's move forward for the engineering implementation of the chaos implementation. We will tackle simulation for the chaos engineering. We will have a matrix. The matrix consists of 4 pillars. Number 1, the issue. What you will configure the chaos engineering tool to impact your infrastructure. Number 2, the solution, and number 3, the proposed solution, and number 4, the expected outcome. So the other part of the matrix is the simulation of such a matrix. Number 1, we will configure our chaos engineering tool by implementing the bots. What we call the bots, it's the number of instances for your microservice architecture. So assuming that we will impact the bots by shutting down one of the bots, what will the solution behavior? What should the solution behave in such situation? Number 1, the solution should provide self-healing, which should be implemented at the infrastructure level. Number 2, the bulkhead. We means by the bulkhead, full segregation of the resources of the solution from microservice to another. So since we are impacting or shutting down one of the bots, it will not impact the other containers, the other microservices. Implementation of the circuit breaker design pattern. So when someone is trying to call this microservice, he will not be able, after a number of trials, to recall it again, and all the calls will be terminated, and you will not impact negatively the unlimited number of trials to impact your infrastructure. And after that, this bot should be terminated. And during the termination, you should have graceful shutdown. What do we mean by graceful shutdown? The graceful shutdown, you are giving the chance for the bot to be shut down in well-defined interval, for example, 30 seconds, in order to be able to handle the remaining business process within its calling stack. So you should review the graceful shutdown. And if you are not defining the graceful shutdown across all your microservices, you should consider that as a level of managing the chaos engineering. Moreover, you should define the HBA, the auto scaling for the microservice. So since you are shutdowning, for the shutdown of the bots, you should, this auto scaling, it will review the defined number of bots and revert it back to the original number, and as needed, it will auto scale the bots to the required number according to the incoming requests. Moreover, if there is impact on the performance of the microservices, that will arise in the reports in that there is impact on the solution performance. So that will trigger implementing caching design patterns. So you should implement number one, cache aside design pattern, and from the database perspective, you can implement indexed table and increasing the solution performance. So in such chaos engineering, it will highlight to you the issues, and then you will take the proper decision for implementation. So accordingly, upon managing such a configuration within the chaos engineering tools, you are impacting the bots, the deployment, and you are checking the self-healing, the bulkhead, the circuit breaker, and all that will be mentioned in the report and highlighted to each team. The architecture team will take the responsibility for forcing these design patterns to be implemented. The infrastructure team will force the self-healing and the auto-scaling definition and managing the buffer of the existing resource. So accordingly, the expected outcomes, the cluster should behave the same. The cluster should behave the same, and impact on the larger scale solution should be minimal. So by implementing such approach, you are mitigating the potential upcoming unexpected behavior of the solution and unexpected behavior of the future. Moving forward, this is at the pod level. Moving forward at the network level, you will configure the chaos engineering tool to impact the network in order to test the resiliency and the latency of the solution. So accordingly, if you are impacting the network by minimizing the quota or that managed by the network, so at this level, you will see how the solution will behave. Okay, the proposed solution, what will be the proposed solution since you are impacting the network traffic? There is latency. Okay, here you can force the architecture team to govern the architecture by implementing a retrial mechanism, as the microservices will face latency, and this latency may exceed the timeout. So according to the timeout, you should implement retry design pattern. This is number one. But what if there is, according to the implementation of retry design pattern, you will not be able to connect to this microservice or this third party? You will implement the circuit breaker as the previous mentioned issue in the bots management. And accordingly, if you have stream of calls that achieve the same business objective, you can implement scheduler agent. This is after the failure of the circuit breaker. You should implement a scheduler agent in order to manage the failed transactions if it's required. And accordingly, if you have streamline of the APIs and there is a failure between the calls, you should implement the Saga, which you will not impact the physical data layer. You are implementing at the cache level first, and then cascade after the success of the transaction at the reflected the change at the database level. Accordingly, if there is network latency and there is a lot of failures, by default you are implementing service discovery. So it will be managed. Sometimes you are facing latency at the load balancer level, and here you should review this model and review the caching model upon the load balancer in order to retrieve the proper instance with higher accuracy. And for sure, the bulk hit, since you are impacting specific services and you are hitting specific services, you should segregate all the resources for such service. And the same for the caching approach. Since you have latency on the network, Don't go and visit the in-depth the architecture model, your architecture model, and go each time, each request to the depth of your architecture. Visit each time the physical database. No, you should have a higher level of caching in order to decrease such latency. And for sure, the enterprise caching should be applied across all your solutions. So this is how can you manage the network chaos engineering. And finally, the CPU and the memory resource utilization also you can manage by chaos engineering. You can configure the chaos engineering tool to يعني impact the CPU utilization and the memory utilization. And here you should have the proper monitoring approach that trigger for you, alert for you the impact on the CPU and the impact on the memory. So here you should have to review the bulkhead, the full isolation. It's a common across all the issues. And accordingly, if you have a failure in the memory, so you are decreasing the memory. So accordingly, some of the pods will not be able to conduct its operations. So it will be shut down, and accordingly, you should have a graceful shutdown and then auto scaling in order to revert the proper amount of the pods to the original size. And if there is a failure of one of the pods of one of the microservices, and some other microservices are trying to execute operations or APIs from this microservice, and there is a failure, you should implement circuit breaker and retrial and the same scheduler agent. And for sure, since you are impacting the CPU and the memory, you should implement enterprise caching. As you can see here within the three cases, there is a standardization of the implementation. For example, the self-healing, the bulkhead, the retry mechanism, the circuit breaker, the enterprise caching mechanism. All of these approaches we have discussed within the microservice design patterns as it touch the resiliency of the solution. And since you are impacting the overall infrastructure performance, this within the cybersecurity triangle, this is the third pillar of the triangle. It's the denial of services. So since you are applying chaos engineering and automating this practice, you are increasing the resiliency of the solution. You are improving your solution architecture at the scale, especially at the government sectors. So I hope the idea has been delivered. Thank you, everyone. If you have any question, you can drop it separately. Thank you.